OTTL is a framework that's primarily used in the transform processor.
If you wanted to do these sorts of custom transformations, you would either need to find another component inside of your already built collector and use those to do your transformations, or you'd have to write that yourself. OTTL allows you to do a hopefully useful but slightly more limited subset of transformations on your data without needing to recompile the collector.
Hi, I'm Austin Parker.
I'm Ken Rimple.
And I'm Jessica Kerr.
And you're listening to Observability Cast, or OLYcast for short, a monthly series where we talk about how we can make production systems more observable, more reliable, and easier to maintain.
OLYcast is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com.
If you're interested in being a guest on this show, or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at OLYcast. That's at o11ycast.
OTTL is a tool, I guess. It's a framework that's primarily used in the transform processor.
What does OTTL stand for?
It stands for OpenTelemetry Transformation Language.
And you said it fits in the transform processor?
That's right. So in the OpenTelemetry collector, which we can get into, the OpenTelemetry collector is a tool in OpenTelemetry all about processing, or I guess receiving, processing, and exporting your data. One of those processors is the transform processor. It allows you to change your data in almost any way. And the reason it can allow you to change your data in almost any way is because of OTTL. OTTL is a framework that gives you access to every single field in the OTLP payload. So your span names, your data point values, your log bodies, attributes for resources, scopes, spans, span events, so on and so forth. OTTL gives you access to all that data. And the transform processor uses the OTTL statements that you write to then go actually change your underlying telemetry.
So you put these little OTTL statements, they're like commands, in the YAML for your OpenTelemetry collector, and then it does stuff?
Yes, that's exactly right. It's not a programming language, but you write strings and they're interpreted by OTTL, and then the transform processor can use that interpretation to go change the underlying telemetry. And you can do that for any signal. I guess that statement's not totally true anymore because we don't support profiles quite yet, although there are open issues and people are asking that we add support for profiles. But in general, the theory is that there's an OTTL signal, the transform processor or an OTTL will be able to modify that information.
So how long has OTTL been around? Is this kind of a newer feature, or has this always been part of the transform part of the module?
So the OTTL has been around, Tyler would know a little bit better than I would, but it's been around for, I'd say at least 3 years, maybe even going on 4 at this point, probably since about, I'd estimate 2021.
Yeah, I think the original creator proposed in late 2021 around like November, December timeframe, maybe even a little bit before that. And then the first implementations were done right at the beginning of 2022, I believe.
And before that, you would have had to write what, like code in some sort of regular language and hook it in?
Exactly. So you would need to note that the collector does not support like live or loadable plugins. So you can't load in, once you've compiled the collector binary, you can't load in code into the collector. You need to do that at compile time. So if you wanted to do these sorts of custom transformations, you would either need to find another component inside of your already built collector and use those to do your transformations, or you'd have to write that yourself. OTTL allows you to do a hopefully useful but slightly more limited subset of transformations on your data without needing to recompile the collector.
Nice. Okay, so who are you and how long have you been involved in OTTL?
My name is Tyler Helmuth. I am an engineer at Honeycomb. I've been working on OTTL and the transform processor since I got started in OTEL, which would have been March of 2022.
And I'm Evan. I am an engineer at Dynatrace. I've been involved with OTEL since roughly June, maybe July of 2022. And I've been involved with OTTL roughly just as long. And then Tyler and I are the primary maintainers of OTTL within the collector.
Nice. What drew you to this particular component?
When I was getting started in OTTL, it was a really good place to volunteer to do work. So I wanted to get involved in the collector, and going to STIG meetings, people were asking, hey, we need to, this is a really cool component. We need help working on it. And I was like, well, I'll help work on it.
Like the transform processor?
Yeah, transform processor, OTTL. So I volunteered to work on it because it's always great to be able to solve problems that people are asking for when you're trying to join a community. And then also, I just really like the concept of it. So the standardization of the ways to transform, the standardization of access to all fields. I just saw the power of that type of capability. And so I was drawn to it.
Yeah, I'm pretty much in exactly the same position as Tyler. It's easy to get started. It's kind of isolated, and you don't need to have deep knowledge of observability or all of the different pieces of the collector. It's fairly self-contained, and we see that a lot with new contributors as well. They'll come in and they'll be able to implement a particular function inside of the standard set of built-in OTTL functions, and they can do this without needing to have broad knowledge of how the collector works or understand the entire code base of OTTL. So that was one thing, but also just, I guess, coming a little bit less from a personal standpoint, more, why my employer has me work on the collector. Dynatrace sees a lot of enterprise customers, and they've got all these sorts of weird use cases. And it was pretty clear to me that OTTL is exactly the sort of tool that's going to be useful for these people.
Ooh. So how are people using it?
It's hard to even really give a concrete example here, but basically just abusing their data in every way possible.
Yeah, that's a good term, abusing the data. And that was a key concept for OTTL, is that it should not be spec'd. You should be allowed to break all OTTL spec with the transform processor if you wanted to.
You can break the OTTL spec?
So your telemetry is not beholden to the OpenTelemetry specification anymore once you're in the transform processor. So for example, if you want to change your data point attributes and not reaggregate, you're welcome to. That changes your metric identity.
It's a metrics thing.
Yeah, if that changes your metrics identity, that could really mess with, if you've got some database that's doing time series metrics, you might have changed something. The data might mathematically not be correct anymore. But if you know that the transformation is safe, you're allowed to do it. So basically, we let you do the transformations that you want where there's not really a lot of hand-holding. Another example is that you could drop spans using the filter processor with OTTL. That could create orphan telemetry, but that's okay. If you know it's safe, you're allowed to do it.
Does the transform processor and the filter processor, do they work on OTLP specifically?
Correct. All processors in the collector work on OTLP exclusively.
Okay, so the input is going to be OTLP and the output is going to be...
Well, so they work on P data, to be more precise.
Sure.
So anything that you send into a collector gets turned into P data, which is an in-memory representation of OTLP. So you are perfectly capable of taking, unstructured logs that maybe you scrape with a file log receiver and then transform them in the transform processor. And it's working on in memory at least, it's working on OTLP, right? But the actual source of the data doesn't matter because by the time it's in a collector pipeline, it is OTLP.
Okay, so the collector receivers, which might be scraping file logs, or they might be receiving Zipkin or Jaeger or Open Tracing or other historical formats, those receivers put that into P data format?
That's right. That's a requirement. All receivers have to pass their data on as P data, which is OTLP.
Okay, so it looks like OTLP.
I mean, it's literally OTLP.
It is, yeah. It's our wrapper around
It's the protobuf, or it's a data structure that is OTLP. All the fields are named the same and it obeys all the rules. And I'm pretty sure it's generated from the protobufs, right?
There's a part of it that's generated, and then there's some additional things.
Some helpers, yeah.
Yeah.
Okay, and that's why you can manipulate all this different data. But then you might export it as some other format than OTLP.
That's right. The processors, like the transform processor, would would pass on its data, whatever it just changed, it passes on that payload to one or more exporters, as many as you've configured. And then it's the exporter's job to transform that OTLP data payload into the exporting format if it's not OTLP. So if there's some backend that wants the data not as OTLP, the exporter's job is to do the translation.
So one of the things that drew me to it was this excellent presentation you had on a cookbook for OTTL. And you've got a bunch of really useful examples in here. I'm just looking at the presentation from KubeCon, but everything from parsing unstructured logs, right? You have data coming in and you're kind of either parsing things out of JSON and putting things into places, or some data coming in that you're kind of putting structure around so it's easier to work with. What are some of the other ones that when you show them to people, it really lights them up? They're like, wow, we've got to do this. We've got to use this tool.
One thing that I really like about that presentation is that all of our examples were based on user questions from either our own customers or from users in Slack. So it was cool to be able to build a talk out of this is what people are trying to do. One thing that I always like showing people that OTTL can do is arithmetic. So a lot of times people will say, I need to know span duration, and I want to do a transformation based on span duration. That one comes up quite a bit. OTTL supports arithmetic, so you can do span end time minus span start time to get the span duration and then compare that against, milliseconds, nanoseconds, seconds, whatever you want to do. Throw that into some condition and then make a change. That one comes up more frequently than I would think it comes up, but it ends up being kind of fun to tell people, oh, we can do arithmetic. You can calculate a duration in OTTL on the fly, and that solves their problem. I like that one.
Oh, I have one that I used the other day, which was pulling some information out of the body of the log and using that to set the severity.
Yep. OTTL can do that. There's open issues to make that even better, because I don't know if when you did it, you might have had to write 10 different statements to handle info, warning.
Yeah, you have to set the severity code and the severity text. And yeah.
And then there's 5 or 6 different cases for the different numbers. And then if you were really going to handle all 29 or whatever it is, log severity numbers, it would be a lot. So we have had some users say, we'd like to make this a little less verbose. What can we do? And we're in talks about that.
Nice. The benefits of a domain-specific language.
So what are some of the limitations? What can't you do with OTTL that maybe if you're going to approach it, you thought, well, this should be something I can do? The thing I'm thinking of that we talked about when I was getting ready was looking at multiple events, right? That's one thing it doesn't really easily do, is looking at multiple messages and being able to process those, right? Doesn't have a concept of state.
That's right. OTTL statements are kind of stateless by default. You can record data between statements in what we have, or a map structure that we have called a cache. That's kind of similar to programming language variables. I guess one of the upcoming things that we're looking to add to OTTL is handling lists of items. So like you're saying, if I have a list of events and I want to somehow consider multiple events in creating a new event or in just processing in general, OTTL doesn't do much list handling right now. That's something that we're hoping to add to the language. OTTL also, if you're just comparing it to general programming languages and maybe not necessarily things that we're looking to add, state is one thing that we're probably not really looking to add. It's just a data processing language. We're not looking for it to be a full-fledged general programming language where you can, use singleton patterns and stuff like that. We're also not really looking to have it make network calls, no infinite loops, so nothing that's going to be an event loop or anything like that. Probably no asynchronous work. I highly doubt that's going to end up on our roadmap. So anything that needs to kind of act as a stateful application in any way, shape, or form is unlikely to be something that you're going to want to use OTTL for, or something that you're going to hope that OTTL could be used for in the future.
Except this cache thing?
Yeah, the stateful statelessness thing is so interesting to me because it's, I think, one of the bigger realizations that people have to come to around OTEL. because OTTL is by default immutable and, practices a lot of things around immutability and statelessness, right? And quite often I see people come in, they're like, well, I just want to do X, and it seems like it should be so easy. For instance, backpropagating decisions or something. And it's like, yes, but if we did let you do that, then that would open up all of these other, the wonderful wide world of mutable data structures and stateful data structures and race conditions and so on and so on and so forth. And I think that I feel like as an industry, we've spent so long telling people, hey, yeah, statelessness is good. Immutability of variables is good. You should do that. And then we never learn. Or at least we have to constantly relearn why it's a good idea.
There's a couple different concepts of state to talk about for OTTL as well. So in OTTL, there are functions. And each statement that you write in OTTL, you define a function like set. Like you say, I want to use the set function to set a value.
Okay, so you're using a function, right? There's a limited set
you're
of
not defining it.
you
Sorry,
can
you're
use.
using a function. They're predefined and it compiled into the collector. At the moment, none of those functions remember anything about the input and the output that they used. We haven't made any rules yet against a function remembering something. That would be a form of state, but we don't have any functions today that do that. For the language itself, what everyone was talking about was more like variable type stuff. Like OTTL, the language doesn't support defining a variable and then 3 lines later referencing that variable and using it. You can't do that in OTTL. The data types that we work with, so spans, metrics, logs, that kind of stuff, we have added a feature like a thing we call the cache, a map. It's outside of the language. And when you're using the transform processor in your group of statements, you can use it to remember things. But then it's forgotten once you go on to the next span or the next log or the next data point.
So could I do things like count the span events?
You can count the span events, but only because we have a function called length that can get the length of a slice. An example of when you would use the cache is, let's say you had a JSON string in a body and you wanted to parse that JSON string into a map. And then you wanted to access different values from that parsed string and use it to set an attribute. You could parse the string and save it.
Oh, so you can avoid parsing the body over and over and over every time you need one thing in it?
Correct. So you could parse the body, put it into the cache, and then reference that in the next statements. But then that would be only for that particular log or whatever. Once you move on to the next log, it would forget about all that.
It's honestly a lot like if you've used Rust, like the way the borrow checker works and where it really enforces things going in and out of scope, right? Like as soon as you iterate past whatever you're currently on, then you lose the context of it.
As you said, Austin, we learn over and over again that statefulness on a global scope is really painful, but we also learn over and over again that statefulness in a very local scope is super useful.
There's a couple more features that OTTL doesn't support that we want to support, and we've got open issues and we're like working on making it better. So I want to call those out too. So the first is the thing that Evan mentioned around dealing with lists. So the idea of I would like to write a statement and I would like to look at a list of items and maybe do certain things to only some of them. So like maybe I want to change only a subset of my attributes and not all of them based on some condition. That looping concept we can't do yet, but we want to do it, and we've got people working on it. Another thing that we can't do yet, but we want to do is dynamic indexing. So say you've got a list or a map, and you'd like to index that map based on a key, but you don't actually know the name of that key. Maybe that key is saved off in another attribute, or it's the name of your span or something. Being able to say, I would like to access my attributes map based on some other field. We can't do that yet, but that would be nice. And then finally, OTTL allows you to set values higher in the OTLP hierarchy. So say you're in a span and you've got a span attribute, maybe even service.name on your span attribute. And you're like, oh, service.name, that's not a span attribute. That's supposed to be a resource attribute. I'd like to set a resource attribute. OTTL allows you to do that. You can say set my resource attribute using my span attribute. But there's a lot of caveats to that, and I won't get into them unless you want me to. But that upward direction setting has some gotchas, and we're working on fixing that as well.
Oh, that is something that I like to do.
Yeah, I do think one thing that's kind of nice about OTTL is like it is technically like independent of the transform processor. So there's room for like either at an ecosystem level or people that want to come in and write. You know, if you do want these processors that let you do funky stuff or stateful stuff, or if you want to promulgate rules across a, cluster or whatever, like you can use OTTL independently of any of this. You could use OTTL if you wanted to extract it and build some sort of like thing that just sits on Kubernetes pods and interacts with telemetry at that layer and lets SDKs go and talk to it. I don't know. Like there's stuff you can do, right? Like one thing that I think I would love for people to think about is like, how can we extend these sort of open telemetry primitives into bigger or more exciting things?
I think that's a great call out. I mean, one of the big benefits of using the collector as opposed to a different similar data processing tool is that it does its processing in an OTTL native format. And you can extend that to OTTL. Since OTTL works with a PData or an OTLP-like structure, it's very OTTL native. And we've leveraged that. OTTL is considered like a Go module. So it's a package that can be reused in any of a number of different collector components. And we've made it so that it, transform processor and filter processor, like we've mentioned so far, but the routing processor also uses it. So you can use OTTL to match conditions on your data as it comes through and figure out where it goes. The tail sampling processor, so you can use it to figure out whether traces are sampled or not. We have additional components as well that are continuing to use it. I think that there are probably at least 2 or 3 others, and people are encouraged to use OTTL as its intention is to be the standard way of directly interacting with data in a way where the operation that you want to do on that data isn't necessarily prescribed. Or if the operation is prescribed, then maybe the conditions aren't prescribed. The goal is that when you're using the collector, you only need to know OTTL and you don't need to know all of these other various expression languages and ways of referring to the data. We've made it so that our paths are hopefully easy to, they're intuitive, they're easy to understand. I have a metric name, metric.name should be hopefully intuitive. And if I want to interact with that data directly, I already know what part I want. OTTL is kind of the canonical way of doing that.
So from a practical perspective then, as people start engaging with OTTL, what are some tricks for things like debugging or understanding what you're doing to kind of help them get started? What would you do to kind of figure out what you're doing wrong?
We get a lot of questions about how to debug OTTL, which is fair because it can be tricky and sometimes the error messages aren't great. We try to make them better, but sometimes working with the parser is just hard. So what I like to do whenever I'm writing OTTL statements is start simple. So normally I have my input data as like a log, and I use the file log receiver to read it in. That way I know exactly what my payload is that I'm looking at. I do my transformations in the transform processor. Then I use the debug exporter with verbosity detailed to print the data out to see what it looks like. And one thing that's really, really important when you're using OTTL or the transform processor or any processor that uses OTTL is to remember that the statements work based on what the collector sees as your data, not how you see it in your vendor of choice's UI. A lot of backends will do things to data. They might transform it a little bit. They might show it as an underscore instead of a dot, or maybe they've renamed the field entirely or whatever. If you think the field name is something, make sure that that is actually how the collector sees the field name. And the debug exporter is really good at showing you what the collector sees as the telemetry. Because if you take your attribute key from your backend and then that doesn't match what the collector knows the data to be, then it's not going to work. We've also added some pretty in-depth debug logs to the transform processor and all of OTTL specifically, actually. So if you went to your collector and you turned on, I believe it's service telemetry logs level debug, the collector is going to start spitting out a ton of debug logs. And some of those debug logs will be the transform processors or OTTL's debug logs. And it'll show you exactly what the transform processor is working on right now, and then what it looks like after the transform processor or OTTL ran a statement. So you can see the before and after, and it'll just log each one of the transformations so you can see exactly how it's changing after each step. And that's quite helpful.
Are you looking long-term at maybe having the ability to put these things outside of YAML? My only thought is YAML is
Great, lovely, wonderful, the best thing since sliced bread.
Is it though?
Tap bread, maybe.
It's not bad. I'm just asking.
I like YAML.
But I mean, I guess my point being, all right, in addition to just having the YAML and editing the YAML, you've got a lot of debug output, which is really helpful, and ways to do that and some techniques. Linting it, anything like that? Is anyone asked for a linting syntax? It's probably very hard to write a linter for this, right?
The short answer is yes. We actually, Tyler and I have had discussions recently with somebody who's done like professional compiler design and has actual programming language experience, specifically I think with Scala. And we have looked into the possibility of putting OTTL into separate files, writing something like an LSP server for it, things along those lines. I will not say that they're on the short list. They're challenging problems in themselves on their own, and they are going to take some time to develop. Somebody's going to have to take that up, but I definitely think that it's possible, and it is something that we'd like to see.
Good first issue. Write the LSP integration.
We'll add help wanted on that.
Yeah, that's a help wanted. But I do think that, it's totally valid because there is OTTL is not Turing complete, but there is a set of rules. Like one nice thing with the fact that YAML and JSON are more, are convertible is that you could publish like JSON or YAML schemas for it. And that gets you a little closer. Like I think something that would probably be like a good weekend, like if someone's looking for like good weekend projects, you could pull in the OTTL parser and Lexer and everything from the collector Go mods and then write just a little, loop that gives you a UI, lets you paste in, some input, and then and then you click go and then it applies all the rules and shows you the output.
A little JS fiddle, but for OTTL.
Yeah.
There's actually, people have asked for a way to try their OTTL statements without running a collector because there's, input and setup for that. So someone has opened an issue for, hey, what if we had an OTTL playground, like the Go playground?
There it is.
Yeah.
Yeah.
The answer is yes, that would be great. I hope someone works on it. And someone did work on it. I don't know if it's live right now, but they posted in that issue a public accessible website that had input OTLP JSON representation, and you could write your statements and then it showed the output. And
nice.
It was really great. So yeah, the community is asking for that, and also the community is responding. So that's an exciting bit of work right there.
Yeah. I was also going to say, like, bonus, since it's Go, you can compile it to WASM and not have to and you just run the actual module in the browser. WASM being WebAssembly.
Very cool. I'm going to point people to the Cloud Native Computing Foundation Slack as a place you could go and look for some of this stuff, right? You can see the conversation going on around OpenTelemetry in there. We'll post your cookbook presentation, of course, and a link to the project itself. Where are other resources people can go to for more information on OTTL?
The big one is, for better or worse, just the package README inside of the GitHub repo. Tyler has a good blog on it. And then we have those two other talks that we gave at two previous conferences that are, in my opinion, slightly better introductions to OTTL. I think that the cookbook was more intended for people who are already using it to maybe expand their horizons a little bit about what it can do.
Yeah, we'd like the OpenTelemetry website to have more docs around the transform processor and filter processor and OTTL and how to use it to select data and all the different components and so on. But as it's just changing so much still, like the collector in general, I mean, we don't have a lot of collector docs in the OpenTelemetry site yet for specific components. We've got a lot of like, how do you run the collector? How do you install the collector? We got a bunch of that stuff, but we haven't moved our individual component documentation to the OTTL site yet.
The collector is changing rapidly?
When I say the collector is changing rapidly, not necessarily for end users, but we release every 2 weeks and the change log is big. So yeah, like a lot of features go out every 2 weeks in the collector. A lot, like contrib is the most actively contributed to repository, collector contrib in OpenTelemetry, and I don't even think it's close. Like the next second most isn't even close to contrib. So we get a lot of engagement on that repository. That's where all of the communities, like the OpenTelemetry owned components live. So there's a lot of features added, a lot of bug fixes. Sometimes there's breaking changes. And so at the moment, we've been keeping all of our documentation in the READMEs still.
Can you tell us about the contrib repository structure and how it contrasts with the other repository, which is just OpenTelemetry collector, maybe?
So contrib and the collector are both fairly similar. So OpenTelemetry-collector without the contrib, without any suffix, we usually call core just because it's the APIs. So a lot of the APIs and a handful of very central important components are in there. So stuff like the batch processor or the OTLP receiver or the OTLP exporters. And those are in there mostly because we want a set of components kind of already in the repo when we go to make any API changes. Contrib is largely organized the same way. So they're both organized with the different component types at the top level of the repo. So you've got your receivers, your processors, connectors, extensions, exporters. And within that, then you have the individual components themselves. And those are all fairly self-contained. Of course, you have other things at the top level, but I think that those are probably, for the average user, the most relevant folders that they'd want to look through.
So from an end user perspective, the stuff in the OpenTelemetry core repository is pretty stable. But then there's in the OpenTelemetry collector contrib repository, there's a whole slew of different components with varying degrees of stability, right?
Yeah. And really, it's best to look at the component specifically that you care about. So each component that OpenTelemetry manages has a stability level for any signal that it supports. So you can go to a component and you can see this is in beta for metrics, traces, and logs, but some other component might be in development for logs, alpha for metrics, and beta for traces or something like that. So it's a good practice to look at the individual components when you're trying to understand the stability levels for what you're running.
And that's in the READMEs?
That's correct, right at the top.
Right. So you go to like github.com/open-telemetry/ OpenTelemetry-collector-contrib/ exporters, maybe if you're looking for a particular one. And then in there, you look for the particular place you would want to export to or whatever. You click in there into that package, and then you look at the README. And then you look at the stability level for the signal that you want. So if you're looking for logs, for instance, and if it says beta, that's actually usually pretty good.
Beta is the top that you could be right now.
Really?
We have defined stable, but we have had a rule that we're not going to call any component that we manage stable until the collector core libraries, the APIs that Evan was talking about, are 1.0.
I also want to add a little color here because I see people talk about like, oh, OTTL's so unstable or not production ready. Part of the reason is that we actually have like really strict requirements for like what stability means and really strict support guarantees. So anything that gets marked stable, we basically support forever up until like any kind of breaking change or any kind of change, really. We have to support the old way of doing it for at least 3 years after that change.
3 years?
Well, that's the whole freaking point of OTTL, is that it's supposed to be a stable platform for instrumentation. We don't want to change things, which means there's a bias away from stabilizing stuff because, we know we're going to have to live with our decisions for a long time. But two, like, we tend to stabilize things
once we have sufficient evidence from the community and production that like it truly should be stable, right? So I think this is maybe something people aren't really as used to anymore, like that level of support for an open source project. If I tried to go use a 3-year-old Node.js library that hadn't been touched since then, I imagine I would be in for a lot of fun times, right? Like how many versions of React have we gone through in 3 years? How many versions of...
And how many months of development effort have we spent on every version bump of React? Oh my gosh.
Or pay for price when you don't.
Right. So OTTL stabilizes slowly, specifically to avoid, one, us burning out a bunch of maintainers and contributors with having to deal with our own bad decisions. And two, because we want to guarantee, we've made promises and we want to keep those promises to our end users. So don't be scared of beta in OTTL.
That's really important. Is this definition of stability a CNCF definition?
No, it's something we came up with.
Okay. And this is a way that OpenTelemetry is compatible with enterprise software development.
I mean, I would say more or less, right? Like it's also just an important thing for everyone to keep in mind is that the goal of OpenTelemetry is to make instrumentation built in, make it native. We want this to be something that just exists without you having to think of it. And the only way to get people bigger than us, to get languages or frameworks or whoever to really adopt it and integrate it is to provide guarantees like that so that they can plan around Java today when I said, okay, I'm going to go write some core framework thing, some standard library stuff that integrates with the OTTL API, like they could know that whatever they write today is going to be good for 3 years. Like that's hugely important when you're trying to do a standards project. So yeah, it's not just like to make it enterprise friendly or whatever. It's to really achieve the goals of the project, I would say.
Yeah, I mean, it's enterprise friendly in the sense that people want to know this stuff is going to still work. And OpenTelemetry as a project is very oriented around that. Meanwhile, for any particular collector component, it sounds like beta is effectively, we don't expect to change this, but we'll adapt if the underlying APIs change.
Yeah, the collector has really strict requirements for what it means to do a breaking change for beta components.
Oh, nice.
There's an entire feature gate process for doing a breaking change against a beta component. And normally that means introducing the change behind a feature gate that you can opt into, eventually switching the gate to be on by default, which then you can opt out of, and then eventually removing the gate. And that's at minimum a 3-release process, which would be 6 weeks, but most of the time it's longer than that. For end user stuff like config changes, feature gates are out there for a while.
Nice. So beta here means something very different than beta in whatever you found on NPM.
Absolutely.
I'd say so, yes.
That's reassuring.
So one thing that I want to call out real quick, just so that we're not giving any guarantees that we can't keep here. For the collector specifically, the guarantees for support are a little bit shorter than OTTL in general. We're not quite as worried about things like somebody, baking instrumentation into the Java standard library. This is mostly used by people run on servers and things like that. So for binary releases, we only give a support guarantee of 1 year. And then for package releases, it's 6 months. And this is after the next stable version is released. If this is the current stable version, it's in support, for as long as the project continues.
That makes sense. Yeah, the collector is easier to upgrade than code that you baked into your library.
And you can react to new things that are coming out and handle them and add new features to it because of that.
Well, thank you for this deep perspective on what's going on in OpenTelemetry and the collector and all the different packages in OTTL. Is OTTL beta?
If only. OTTL, last year at KubeCon in 2023, we stood on stage and said, it's almost beta. And then both Evan and I worked on a lot of other stuff in 2024, specifically getting the collector to 1.0 instead of OTTL. So there is one issue left. There's a tracking issue that you can go see if you want to look at where OTTL's status is. There's really one issue left right now, and we've got a very active contributor working on it. It's kind of a complex one. They've been working on it all fall, and they're making great progress. And really, as soon as that issue is closed, we'll mark OTTL as beta, as long as there's not some other big thing that comes up. But when it comes to the configuration of OTTL, we don't foresee any big breaking changes. So we're really close. But we did the thing that OpenTelemetry in general did and said that we were really close, and then a year later and we hadn't finished it yet. But that's okay. Someone's working on it now. And we're really thankful for the community members that contribute to OTTL, because Evan and I are busy doing a lot of stuff in collector land and outside of collector land. And so it's really helpful when we get new contributors doing things.
Great. So when someone wants to contribute, where should they go?
Collector contrib, and you can look for issues that are marked help wanted. And if you're really new, also include good first issue.
Yay. That's great. And where can people find more from the two of you?
I don't use social media, so my GitHub handle is Tyler Helmuth. You can reach me there. It's the same on the CNCF Slack. If you wanted to find me, it's the same name.
Yeah. Mine's Evan-Bradley, or just Evan Bradley on CNCF Slack.
Great. Thank you.
Thank you very much. This was a great conversation.
That's all we have time for today. If you're interested in being a guest on this show, or if you would like to suggest a topic, find us on Twitter at o11ycast. That's o11ycast. OLYcast is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.